All right, everybody, welcome back. Hopefully that first lesson went okay. I know there's definitely some things that I learned. But the first thing I want to do on this lesson, I want you to give me any feedback possible. This is obviously a learning experience for everyone, so I want to make sure that you guys are comfortable and are understanding what to do. So this is just an open-ended question. First of all, did everything work okay? Were you able to log in? Was anything confusing? Did you think it was too much work? Was it not enough work? Was anything confusing? Or just anything else that you'd like to add or let me know. So please, and that can be anything. It can be any of the assignments. It can be the previous video. It can be the calendar with the video chat hours. So just let me know anything that you feel about the very first lesson. You can just say it went great if everything went great for you. But if there's something that stuck out or something that was confusing, please let me know. So take a second and answer that and let me know what you think. All right. For IXL, there was basically two types of questions that it was giving you. And something that I noticed when I looked through your guys' progress, some of you spent like 2 hours and it said that you did like 80 or 90 questions, okay? I went into IXL and I was able to get to 90% or a SMART score of 90 with 16 correct questions. So I answered 16 questions and I got to 90. So just be careful. Every time you miss an answer, it moves you down, I'm sure, as you now know. So be sure that you're answering correctly. And there's buttons for help. You can push that button and it gives you an example. You can wait and ask questions. You can email me. You can join the video chat at 1 o'clock with myself. So just make sure you're answering those questions correctly anytime we're using IXL, and you'll get to 90 faster. Okay. So number one, I want to go over like one of each of these that you did in the last IXL practice. So this one here, the first type of question, notice there's 2 logs on the left side, but there's no logs on the right side. So this is actually kind of a combination of a couple things we've done in the past few weeks. So first of all, I can condense the left side by dividing y and 3 because those 2 logs are subtracted, right? That's condensing. So if we condense log base 15 of, this becomes y over 3. Okay, so we condense that by dividing, and now the right side is just, it's still just a 2, right? So that equals 2. Now, in this case, you cannot set y divided by 3 equal to 2 because there's not a log on the right side. So this is actually one of those scenarios. One of the very first things we did when we did the war cards and the very first lesson, we can just convert this into an exponential. And we do that by writing the base raised to the power of the right side equals the stuff in the middle, which in this case is y over 3, the stuff that's being logged. And to solve for y, we just need to multiply 3. So 5 squared is just 225 equals y over 3. And then to find y, we just multiply both sides by 3. We'd multiply that 3 to the left, so y ends up being 675. So that was kind of a combination of condensing and kind of converting a log equation into an exponential equation, okay? Number 2 was a little bit more like what the last notes were over. So once you did a few of the ones on number 1, it eventually got to the questions that look like number 2 here, where notice there's now a log on both sides. That's the main difference. When there's a log on both sides, you can set what's being logged equal to each other. So this is actually just basically just a quadratic equation. So we have t squared plus 3t minus 1 equals negative 2t plus 5. And now we just have a quadratic equation. So I'm going to get this set equal to 0. So I'm going to add these 2 t's to the left. And I'm going to subtract. So now we have t squared plus 5t. And then if I subtract this 5 over to the left, we'd have a negative 6. So minus 6. now equals 0. And this is just a quadratic that factors very easily. So the factors of -6 that add up to 5 would be -1 plus 6, so t minus 1, t plus 6. So therefore, t equals 1 and t equals -6. Okay, and you can always check your answers to see if you end up taking a negative log. So for example here, if you look at the right side, if I plug in -6 for that, let's see what happens. So this is just the common log, so log. And once again, hopefully you've downloaded a computer or a calculator by now. The one that I've used is the calculator X85 or 84, I think it was. But let me know if you need help finding a calculator. So if I do log of -2, and we found out that t could be -6. So if I plug in -6 here, plus 5, we get this decimal, which is 1.230448921. So this does appear to work because it's a negative times a negative, right? Plus 5. So that right side works. Now let's plug it into the left side. So make sure when you're plugging in a negative number to be squared, you put it in parentheses in the calculator. Plus 3 times -6 minus 1 is the left side. That comes out to the exact same thing. So you can see 1 definitely works, okay? And then you could -6 works. You could then plug in t is 1 and see if that works, to see if, because you can never take the log of a negative number. So if the inside, if the blue part comes out to be negative, it's not going to work. It's going to be extraneous. But you can plug that one in and you'll see that that one works as well. So therefore we have 2 answers. And it says when you type them in, just separate them with a comma. Okay, so make sure don't make any silly mistakes, because then it's going to make your smart score to go down. So just 1, -6, or vice versa. All right, now kind of moving on to our lesson for today, just a quick review of the things that we have learned. So number 1 is a log equation, but there's only a log on one side. When there's only a log on one side, what we've done is we converted it into an exponential. So I would write this as the base raised to the power of the right side equals x. What's being logged, right? We did that. That's the very first thing we did. So we basically just solved this equation, right? So therefore x equals 8. 2 to the third power would be 8, right? So that's the first type of log equation we learned how to solve, just by writing it as an exponential, okay? Number 2 is an exponential equation. Now you could convert this into a log, or what we've kind of practiced doing is, if you can, rewrite the right side as an exponential to the same power. And I can do that in this case because 3 squared is 9. Once the bases are the same, once they both have the same base, we know the exponents are equal. So therefore x equals 2. Okay. Number 2, or sorry, this is also number 2, that should be number 3. The log here is kind of the same version of number 2, it's just the log version. If there's one log on both sides and they match, kind of like having the same base on both sides, the exponential, then that means what's being logged is equal. So this is like about the easiest equation I could possibly give you, x equals 7. And then lastly, what we've learned more recently is if there's not one log on both sides, or if there's multiple logs on one of the sides, we have to condense them. So in this case, we could do that by, in this case, the logs are added. So I would multiply what's being logged. So in this case, 2x times 4 is 8x equals log of 8. And then once there's one log on both sides, we're basically back to the previous example. We now know that 8x equals 8 because there's one log on both sides. So 8x equals 8. Divide both sides by 8, therefore x equals 1. Okay, so this is what we've learned previously up till now, all the different types of equations that we've learned. Okay, and if I went kind of fast there, feel free to pause it, go back, rewatch it, whatever you need to do to make sure you understand each of those. Moving on is our new lesson, and I put this as a PDF on Module 2. If you need to, or if you can print it out and write on it. If not, you can just write these examples in your notebook. Make sure you want to definitely write this down as we go. So just take notes in your notebook, and then you can just pause it after each example if you need some extra time to write down the examples. Okay. So today's lesson, to solve an exponential equation in which the two sides cannot be written with the same base. Okay, we recall this power property. And that's really important today because when a log of m has a power, remember that power can be moved out front. We've done that a few times. So for example, if I had 2 times log of x, that is the same thing as log of x squared. And that's going to be very important for us today. Today, I think this is actually one of the easiest lessons that we do all year. It's kind of cool, though, the way that it works, okay? So we're going to solve these equations, and the steps that we're going to solve them, first, we're going to use SADMEP, or subtracting, adding, dividing, multiplying exponents in parentheses in that order. These are our inverse operations to solve for a variable, right? It's PEMDAS backwards, okay? So we always want to get the exponential isolated. And on number 1, the exponential is 6, the base of the exponential, 6 to the 2x minus 1. So we want to get that by itself first. Okay, so the first thing that I'm going to do here is I'm just going to multiply that 2 to the right side. So I now have 6 to the 2x minus 1 equals 36. So that gets the exponential by itself. Kind of like if we were doing an absolute value or a square root or whatever kind of function it may be, we always get that, whatever the x is in, by itself. Okay? Step 2 up here at this. So we did step 1. Step 2 is we can attempt to write both sides of the equation as the same base, or an exponent to the same base. And this one, you can do that because 36 is just 6 squared. So in this case, we can write both sides as the same base. And once again, we've done this before. If that can happen, then we just set the exponents equal to each other. So now we just have a really easy algebra 1 equation, 2x minus 1 equals 2. Add 1 over, we get 3. Divide by 2, we get 1.5 or 3 halves. Okay? So really easy there, just get the same base on both sides. If you can do that, that's always an option for you. So that's why I put one of these on there, just to remind us that we can do that if it's possible. Okay? But that's not always going to be possible. So for example, let's go over to example B. So in this case, the exponential part of the equation is 3 to the x. We need to get that by itself. So if I subtract this 1 over, we'd get 11. Now, 11 cannot be written as a base of 3, like 3 squared or 3 cubed or 3 to the 4th power. It can't be done, okay? So this is the first time we've had this scenario where x is up in the exponent, but we can't get it down because we can't write 11 as a base of 3. So watch what's going to happen here. Step 3 says if you cannot do step 2, you will log both sides of the equation with the same base of the exponential. Now logging is just it's just an operation, just like you can multiply to both sides, you can divide both sides. Logging is an operation. So we can log both sides, and you want to log both sides with the same base as the exponential. In this case, the base of the exponential is a 3 to the x power. So I can do log base 3 both sides of the equation. Now, the reason this is so helpful, because it is the left side is now a logarithm, log base 3 of 3 to the x. And anytime we have a logarithm, we have that property that allows us to move the exponent out front. And that's the key to this technique. So we now have x out front times log base 3 of 3 equals, but you also have to log base 3 the right side. So that's it's just like multiplying both sides or adding to both sides. You have to do it to both sides. So the right side now becomes log base 3 of 3. Okay. And the reason we use the same base, log base 3 of 3, log base 3 of 3 is just 1 because 3 to the first power is 1, right? If you remember back to our war game with the cards on in the deck. And you could put that in your calculator. The calculator that has it's called the I forgot what it's called, the TI whatever 84X that I was talking about earlier. It has a math button, and when you hit math, you can scroll down and it says log base, and that allows you to do a log base other than whatever log base 10. So in this case, if we do log base 3 of 3, it's just 1, right? So that's why this is so important, because that just cancels out. And we now have x equals log base 3 of 11. And you can type that in. So do log base 3 of 11, hit enter. And obviously that's a decimal because 3 to a power equals 11. It has to be a decimal. And I think for this lesson, let's round to 4 decimal places. So 2.182, and then we'll say 7. That 6 rounds up from the 5 behind it. So x equals 2.1827. Okay, and you could check that if you wanted. If you wanted to go back to the original equation, you could do 3 to the, and then if I put that number in, and then do plus 1, boom, 12. So you can see that original equation did work. And that's really the extent of this lesson. We're just going to do that over and over. So I'm going to do it a few more times. On example C, we have it's just an inequality version of it, but it doesn't really change the way we solve it, unless if you multiply or divide both sides by a negative number. Remember, you have to flip the sign. But here, the exponential is 5 to the x. And it's already by itself. There's nothing else in the way, like on letter A and letter B. Letter B and letter A. I said that backwards. So in this case, we can actually just log, and you want to log base the same base of the exponential is greater than or equal to, but then don't forget to log base 5 the right side. So that's what that looked like. It looks, I know it looks kind of weird. It's just kind of like multiplying both sides by 5 or whatever it may be. It's an operation. So if we log base 5 both sides, that allows us to bring the x out front. So now x is by itself. Log base 5 of 5 is 1. So we have x is greater than or equal to log base 5 of 62. And that's your answer. That's just a decimal. So once again, in whatever calculator you're using, log base 5 of 62. So that means x is greater than or equal to about 2.5643. Alrighty. Letter D, I put this on here because sometimes we have decimals. So it's kind of weird with decimals, but the exponential is by itself. The base to a power is by itself. So it's kind of weird, but we're actually going to log base 8.2 both sides because the base of the exponential is 8.2 to the n minus 3 equals log base 8.2 of 42.5. And I'm gonna, while this is on my mind and before I forget, the EOCs this year, I don't know if you have heard, are actually canceled. So we will not be having an EOC this year. Just keep that in mind. But you want to make sure that you continue to learn this stuff. If we do go back to school, we'll probably eventually test over it. But you'll definitely need to know this stuff as you go on in your math career. So next year, if you take pre-calc or college algebra, whatever it may be. So that's why we're still learning, still important. But good news that EOC is canceled this year. So just wanted to say that before I forgot. All right, let's go back to this example here. So this time the exponent is n minus 3. So n minus 3 moves out front. So really all I have is just n minus 3 because the log base 8.2 of 8.2 cancels. Anytime you have a log base of the same number, it cancels to 1, right? And then I have log base 8.2 of the right side. And to get n by itself, you just need to add 3 over. So add 3 to the right side. So when you're typing this in your calculator, you can just type it in exactly like that. So if you do log base 8.2 of 42.5, and then whatever that is, some decimal plus 3. So in this case, n is equal to 4.78, and then we'll say 20 because the 7 rounds up to 9. Okay. Letter E is very, very simple, or very, very similar to letter C, as well as kind of a combination of what we just did with this n minus 3. So I'm going to have you do letter E on your own. So do letter E, and then if it comes out to a decimal, round that decimal to 4 decimal places. Make sure you round it correctly, okay? So go ahead and do E on your own, and then submit your answer. All right, the last thing we got to do here for solving is letter F. Natural log of E equals 1, because remember, natural log is just log base E. So kind of like what we've been doing over here, log base E of E is 1. Those cancel out, right, to 1. So when we're solving this one, first thing we need to do is get the exponential by itself. So E to the x over 3. So if I subtract this 10 over, we get E to the x over 3 equals 4,260. Okay, now the way that we would cancel out E is log base E both sides, aka natural log. So if you natural log both sides of the equation, that exponent moves out front and just becomes x over 3. Natural log of E cancels, and then on the right side we have natural log of 4,260. So natural log, that's why we learned about the natural log, is it cancels out E because it has a base of E. So now to get x by itself, you just need to multiply that 3 to the right. So whatever we get times 3. So let's type that into our calculator. And for this one, there should be a natural log button on any scientific calculator. So natural log of 4,260. Make sure you close your parentheses though, because then whatever that is, we want to multiply it times 3. So in this case, x is about 25.0711 if we round that 7 up. All right, I want you to go ahead and do letter G on your own, okay? So very similar to the one we just did, get the exponential by itself first. So you need to get the 7 out of the way and the 5 out of the way, get the E by itself first, and then solve it the way we just did F. Okay, so go ahead and solve this one out and then submit your answer into Edpuzzle. All right, now H is just a review of natural log, kind of like what we did last lesson and what you did on IXL last class. Remember, natural log is base E, and if there's not a log on the other side, we can always convert that into an exponential by writing the base raised to the power equals what's being logged. So in this case, if I wanted to solve this equation, just divide by 5. and then x equals e to the fourth divided by 5, whatever that is. You can put that into your calculator. Okay, so that was just a quick review. I know this lesson's a little bit longer. I will not be assigning a new lesson on Friday, however, though. A lot of math teachers are doing a lesson every Monday, Wednesday, Friday. So this will be your last lesson for this week. So Wednesday, due on Friday, but I'm not going to assign another lesson on Friday this week, okay? So I'm not going to do all these. I just want to do one of these examples because a couple weeks ago I said, we don't know how to do this, so just guess and check. But now we know how to do this. So quick review, we're just going to do this one word problem. Compound interest formula, remember PE to the RT is when we're compounding interest continuously. Okay, so let's do example 2 here. So it says, suppose you deposit $1,000 into an account. So that's the principal. So the amount equals the principal times E. Now 5% as a rate is 0.05. Remember, we moved that decimal to the left 2 spots. So the rate is 0.05. And then time is 10 years. So this is a review of what we did like 2 or 3 weeks ago when we did compound interest formulas. And this is actually the last lesson in ES5, okay? So we're not going to test on this until we get back, but we'll review some. But just so you know, we are done with exponentials and logs after this lesson. So just type this into your calculator, 1,000 e to the 0.05 times 10. So after 10 years, we'd have $1,648.72. Okay, so once again, that's just a review of the PERT formula, what we did a few weeks ago. But B is really what we've learned recently. Okay, so this time they want our account to be at least $1,500. So you could write this as an equal sign, or if you wanted to, you could write it as an inequality so that the right side is greater than the left side. But we take that principal amount, which was 1,000, E. We know the rate is 0.05, but in this case, we don't know time. So 0.05 times time. So a couple weeks ago, I just said, plug the right side into your calculator and check and guess for T. Try and get as close as you can to $1,500. But now we know how to actually solve this equation. So if you divide both sides by E, so this is exactly what we did in today's lesson. So if you divide both sides by 1,000, and then get that E by itself. So we get 1.5 on the left is less than or equal to E to the 0.05 t. Now we just learned this. Anytime you have a variable in the exponent and we have a base of E, we can actually cancel out that E with a natural log. So that exponent comes out front. This cancels out, so we get 0.05 t. And on the left side, we now have natural log of 1.5. Make sure you do natural log to both sides. And then to get t by itself, you just divide both sides by 0.05. So divide by 0.05. And that way, we can put that into our calculator now. Natural log of 1.5 divided by 0.05. So time needs to be, basically we found out it's going to take at least 8.1-ish years. So if we write this with t on the left, so t will need to be greater than or equal to 8.10, if we go to 4 decimal places, 93 years. Okay, so feels kind of good that we now know how to solve that equation. All right, that is all for today's lesson. Thank you for listening.